Hello everyone. Today our topic is requirement engineering. This is Dr. Rachita Mishra speaking to you, and we have in the previous lessons of software engineering we have covered the process models. We have discussed about how process is important for software engineering. So in this lesson we will take up the first phase in the software engineering process, which is the requirement engineering. The topics that we will cover in this lesson is what is requirement engineering. We'll try to find out what is requirement and how we can define a good requirement. Then why we should have the requirement engineering phase, why is it necessary. Then we will see what are the activities or the tasks that is done in this requirement engineering phase, and finally we will see the output of the requirement engineering, which is the requirement specification. So what is requirement engineering? RE in short. So we have to say what is requirement and then what is engineering. When we say a requirement, what we mean is that it's a function or a feature or the behavior, or in other words any constraint or any specific property that the software that we are going to develop will need to provide to the users so that the users will fulfill their business needs. So whoever is the intended user of the software solution that we are going to make, those users, they have certain business needs for which they are giving us the requirement. It defines functions, it could be features, behaviors, constraints, or any other property. What is engineering? It is the discipline of using systematic and repeatable techniques for producing software. We have seen what are the engineering characteristics in other core engineering or manufacturing, and now we are basically understanding, we are trying to take the different aspects of the software engineering. So together when we say requirement engineering, it therefore includes the process, the systematic process to collect the requirements from the users, because the user will be using the software, that is the software product, and the techniques that we will use to analyze these requirements, document them, validate them, and manage them in a systematic manner. Those things are part of our requirement engineering. So let's look at what is a good requirement. When do we say that the requirement is good? It should be, first of all, it should be clear and unambiguous. When we say it should be clear, it should have certain structure so that it will be easy to understand, easy to read, easy to understand. It should be unambiguous. That means the interpretation should be single. It should not have ambiguous interpretation. That means it should not mean something to one person and something to the other person. Not more than one requirement in one sentence. So we should not club requirements together. We should separate them and write it clearly. So that is what is the clarity and unambiguousness. Next is it should be correct. Correct means it should be the real need, what actually the user needs for doing the business. So it will contribute to their work. It should not be something flowery or like a jewel. We should not think of extra features which will add a burden to the software. So we should only take those which are very much required by the user to satisfy his real need for the business. Then it should be understandable. The functionality and the objective of the requirement should be easily understood by the reader. Whether it is, this reader could be a team member, he could be a product manager from the customer side, or he could be any other person. But it should be written in such a way that it can be understood. The verifiable, that means it should be in the form in which it can be tested or validated or reviewed. So we can check whether the requirement is correct or not. It should be complete. In other words, there should be no omissions, nothing should be left out. It should be consistent. That means different parts of the requirements should not have any conflict. That is what we mean by it is consistent. And finally, it is traceable. Traceable means the feature or behavior can be tracked to the design and construction. We should be able to track it also to the origin backwards, and this is the forward, that is the forward way, tracking a requirement to the design and then to the construction. We can also track it backward to the person, to the user who has given us the source of the requirement. So why requirement engineering has to be done? What is the importance of it? Requirement engineering activities are initiated in the communication phase of the generic process model that we have seen when we discuss the process, the importance of the process and how the process models are designed. And we have seen that it is done in the communication phase where where the engineering team is actually discussing with the customer. It establishes the foundation for design and construction. So it lays down the base, the foundation. So if you have you can think of it like constructing a house. When we construct a house, we first dig up the ground and we lay the concrete and the steel and everything and create the foundation. And if the foundation is strong, then the building can be strong. So in the same way, the requirements, a good requirement will form the foundation to the design and construction. That's why requirement engineering is considered as the base activity for the software development. If we don't do it, then the software has a high probability of not meeting the customer needs because we have not understood the customer's needs. The software engineering team must understand the requirement and what is the problem before the team tries to provide the solution. So, understanding of the problem that the business users are facing and what is their actual need, that has to be understood by the engineers who are developing the software. In some cases, requirement engineering may be abbreviated. That means it can be shortened, it can be compressed, but it cannot be limited. So if you have a small project, maybe you can eliminate some of the activities in the RE process. RE actions and tasks start with the communication activity and continues into the modeling and specification activities. Why getting a good requirement is hard? It appears that if this is that we are just having a communication with the customer, then why should we not get it? And sometimes software engineers tend to think that giving the requirement is the customer's job. So why should we bother about it? Whatever they give us, we will just take it and we will make the system. But actually it is not like that, because unless the system team interacts with the user, it is difficult to get their actual requirement. What they give may not be what they meant. So the stakeholders often don't know what they really want. They are unable to express it properly. So that is what I meant by saying that whatever they might have given to the team, they may not have meant it. They might have meant something else. The way they have expressed it may not be proper, or it may be poorly expressed. Different stakeholders may have conflicting requirements from the software solution. There could be two different type of users who will use the software solution. They look at their problem in a different way, and their expectations from the software solution may be different, and it could be conflicting. So when you get the requirement, there could be something conflicting in it, and therefore the software engineering team has to get involved in the requirement analysis and the requirement gathering along with the customer and try to resolve these things. Stakeholders express requirements in their own business language and terms. So when stakeholders have written their this requirement specification and they're given to the team, then what will happen? They do not know the computer terminology. They do not know design terminology. So they will write in what they are used to, that is their business domain terminology, and it will not be, but the software engineer is not familiar with it because it is not his functional domain. So there is a mismatch in what they say and what we understand. Organizational and political factors also may influence the requirements. The requirement change during the RE process. So when we are doing the requirement engineering, sometimes the requirement may change. And why it will change? Because the business scenario may change or some new stakeholder may emerge. So because of these two reasons, there will be some change. So now we know there are so many reasons which may create some problem for us in getting good requirements. So that is why we should understand the RE processes very properly, very nicely we have to understand. So what is the process that we take? That means if requirement engineering is one phase or one larger activity, what are the smaller actions or the tasks that we have to take to see that this requirement engineering is successful and we are able to get the good requirement? So it starts with the inception, moves to elicitation, then elaboration, negotiation, specification, validation, and management. So let's look at the meaning of each of these words. Inception, that means we have to start. Inception means we have to basically initiate. This is the initiation stage, and we have to identify the stakeholders and establish a basic relation with them and an understanding of the problem and the nature of the solution, what exactly they are looking for it, in a very broad, in a very overview kind of view we will take at this stage. Then we have to go to the elicitation. When we do elicitation, that we have to do collections. Elicitation means collections, collection or gathering or extracting. So we will have to extract more details of the requirements from all the stakeholders, because this is only an overview. This is the problem statement and the solution statement. It's like a statement, but we have to go into the details and get it. Then after getting the requirements, we have to elaborate it. That means we have to analyze it in various ways, and we have to create some models that will represent the information aspect, the functional aspect, the behavioral aspect of the requirements. And why we do this? Because this what we have collected so far is in the business language, in the terminology of the business. So we need to convert it into another language which we can follow, which the team can follow, so that it can be properly, it can be converted to a proper software design, and it can be converted to the construction, the code, the source code. So that is why this elaboration is very important, and it normally has a very highly structured techniques that we will follow. Then we come to the negotiation. When we come to the negotiation, we agree on the deliverable system, because here when we see there may be extraneous requirements, and that extraneous requirements may not be possible to do within the budget or the time requirement of the customer. So therefore we have to be realistic on the scope that we will take. How much requirements will be included in the scope has to be realistic, so that it can be completed within the constraints of the project. So that is what is the negotiation phase. Then we come to the specification, where we describe the requirements in a formal method, and also some of this in an informal way. Then we come to the validation. So whatever we have specified based on these analysis and the negotiations, that we will review here. And when we review it, we will review it along with the customer, so that all the errors, ambiguities, omissions, conflicts, these can be removed. Once it is removed and the requirement is in the final form, then it will go for management, because now it is like a contract, it is finalized, it is baselined. So now we have to do the management. So once we have baselined it under the management, then during the development team, the design and the construction going on, there may be some change. So we have to keep it under change control, and we have to manage the change to the requirements. So let's look at all these tasks one by one. What is inception? The aim of inception is to effectively communicate and collaborate with the customer, and establish which is a key to the development process. So we have to establish this correlation, this collaboration, or a mutually beneficial relation between the customer and the developer. And this collaboration will be the key to the development process. And whom we will contact among the customer? We have to take care of the stakeholders. In the customer organization, whoever are the stakeholders of the problem or the solution will be the people with whom we will establish this collaborative relation. So let's look at who is stakeholders. They could be users in the customer's organization, or they could be external to the customer's organization, but they are user of the system. And members of the developing organization, that is the developing team, but they are outside the development team. So the members of the development team are one kind of stakeholders. Also certain members of the developing organization, but outside the development team. So these people, we actually in the inception, in the requirement engineering, we don't really involve these people, but the members of the developing team and these members of the customer in the users category, either in the customer's organization or external to the customer organization, but both are in the user category and the developing category, they become the major stakeholders in this inception activity. And there has to be a collaboration between these. And what we will do during that time, we will ask some questions to the customer related to the problem to establish a basic understanding of the problem, and the people, to understand who are the people who will use the solution, and the general nature and behavior of the solution that is desired. So that means we will get a very high level idea about whom to discuss with, what to discuss, and what is their problem. Then we come to the elicitation. Elicitation, or in other words, extraction or obtaining the requirements. All type of requirements has to be obtained from the customer or the users and others relating to the problem area. Anybody who is related to the problem area becomes part of the team who will be collaborating in the elicitation activity. Now what we will do, what are the tasks that we will do? Finding out from the customer the objective of the product development, why they want to do this, what they will achieve, what is their goals and what is their objectives, what they are looking for as the nature of the solution. So they must be having something in their mind, what the solution will provide them. So that nature of the solution as per their view has to be understood. Then how the product help in meeting the business needs, and how the product will be used on a day-to-day basis for each user type, because these users, customer users, may be having different roles or different types. So each one will have to, we have to get the information from each type of user, how they will use it. So this kind of information has to be extracted from the customer. So what is the difficulties? Is it very smooth, or is there any difficulties? What are the hindrances normally it is found? So there could be problems of scope, there could be problem of understanding, or there could be problem of volatility. So when in the under the problem of scope, there will be things like that when customer gives the requirement, he is not able to create a boundary of the system or the software. That means it is open ended. So we have requirements which are open ended, kind of it can be added later. That means it's kept open. They don't know, they have kept it open, which they will tell later. So that there is no clear boundary. The scope is not bounded or limited. Customers and users specify unnecessary technical details that may confuse rather than clarify objective and the scope. So sometimes they give lot of details which are not required, and they also try to give technical details which is not useful to the engineering team. So that could be one of the problems, to be able to specify the scope or the set of requirements that will go into the project scope. Then comes the problem of understanding. So this is a very serious problem because customers often don't have full understanding of their own problem, and they are not completely sure of what is needed. That means what the solution will be, or they have trouble in communicating the needs to the system engineer because they don't know how to express it. Customers do not have good understanding of the capabilities and limitation of the computing environment. So sometimes they have they do not know that there are certain limitations. So they might ask more than what can be provided, and sometimes they don't know what is the capability, so they cannot tell everything that they need. Customers omit details that is believed to be obvious. So what they do, because they are very familiar with the business, so when they describe the business needs, they don't go to the details, because to them it is obvious, they are familiar. So to them it is obvious, they are trivial, but to a system engineer or a software engineer it may not be trivial. Because the software engineer is not familiar with their business environment. And then customers specify requirements that conflict with each other. So the conflict is always a very major problem, and therefore it is very confusing to the software engineer. So that is a very big problem in understanding what really they want, because they may go against each other. And customers specify requirements that are ambiguous, or we are not able to validate it, we are not able to test it. So these are some of the problems that we have in the understanding of whatever requirements that the customers provide. Another major problem is that it is volatile. That means it may change over time. Even when we are doing the requirement engineering, they may say the different kind of requirement may crop up. Then we come to the next phase, which is the elaboration. This phase is often called as the requirement analysis. Many authors, when they write books or they write papers, they call this elaboration phase as requirement analysis. What is the aim? The objective is to develop refined models of software functions, features, constraints by analyzing the information obtained during inception and elicitation. So during the inception and elicitation, we are communicating with the customer. So we have received some information regarding the problem and the kind of nature of the solution, what features they are expecting from the software solution. So these information that we have obtained has to be analyzed and converted into some kind of models. Why we want to make the models? Because then we will be able to properly view the software functions and the features, and it will help as these models will help us in converting it into design activities. The analysis models help for the software design activities. The tasks taken up are, these are some of the kind of actions that we take during this elaboration phase. The first one is user scenarios. How the user is actually interacting with the system. The way the end user will interact with the system, those scenarios or like kind of stories that they will describe in the requirement gathering phase, those will have to be modeled. They have to be refined and they have to be modeled, and when we model it, we have to use some standard techniques. It is called scenario analysis or use case analysis. So scenario has to be analyzed, and use case, that is use case is normally created with the unified modeling language. So we can convert it into use case illustrating the different user types or roles. So there will be different types of users, and they will have a different function flow with the software solution. So each user, how he interacts with the software, and what are the major functions that they satisfy by interacting with the system. That is what is modeled in the use case, and the scenarios are the base for the use cases. The events in the scenario and the use cases are then parsed and extracted, and these are created, they are converted to data analysis models that identifies data and also functions or processes, then class, relations, and other behavioral requirements of the software system. So you can see that in the analysis is mostly done by the software team engineers to give a better language, a better way of writing the software than the way the business users have given. The business users have given more in a descriptive manner, and that is converted to a more structured and model or prototype method. The end result of the phase is models and structured documents that define informational, functional, and behavioral domain of the problem. So the different aspects of the problem or the different features of the problem is described. Then comes the negotiation phase, where the whatever are the requirements that we have gathered and analyzed, those are discussed with the user. So the aim is to agree on the deliverable system that is realistic both to the developers and customers. So the requirements are categorized and organized into subsets, and the relations among the requirements are identified. So related requirements will come to one set, and also they are reviewed for the correctness. So the customer will check whether it is correct or not, whatever they have said is properly understood or not. Then they will be prioritized based on the customer's needs, because the customer knows which of these subsets will have more value to them. So depending on the business value or the customer's requirement, their need for the conducting the business, they will be prioritized. The high priority will have to be taken up into the project. Negotiations about the requirements are carried out with customer to fix the project scope, how many of these prioritized requirements will get into the project scope based on the cost and the timeline, because the customer will have a timeline by which they want the software, and that if we don't satisfy the timeline, then their needs will not be satisfied. So the customer has a time to market or a need when he has to shift from whatever he is doing to the software solution. So the timeline is more or less fixed because of them, and also the budget that they have in mind, that also is more or less fixed. So within this cost and timeline, how much scope we can take, that has to be negotiated, and the project scope, cost and timeline has to be finalized. There should be no winner and no loser in the effective negotiation. It's a negotiation, it's a discussion. It is not a win and lose kind of situation. So nobody should take it as if it is a game or a fight. It is a way of understanding the customer's timeline, the customer's budget, and the customer's important prioritized needs. Then we come to the specification of the requirements. So the aim here is to create a well-defined set of requirements to which all stakeholders will agree. So sometimes specification may mean different things to different people. There may be different interpretation to the specification. So that is the challenge in creating a good specification. So many times a specification can be written as a structured document, or it can be given as a graphical models so that it is easier to understand, or sometimes you can have some mathematical models, some rules, some tables, or any other formal language may be used to express the mathematical models, or there may be some algorithms. Then collection of usage scenarios or use cases, the way the user will actually use the system from the start to the end. So that's the scenario. A prototype showing the user interaction and the outputs. A prototype or a model can also be included in the specification, and also it can be a combination of the above. That means it can have some amount of written document, some amount of model, some amount of use cases and things like that. So a combination of these things normally constitute a specification. The formality and the format of a specification varies with size and the complexity of the software to be built. If the complexity is very large or the size is large, then the formality is higher and the format is more rigid. It is a well laid out format we have to create, and sometimes we use a kind of a standard format. For large systems, well documented language descriptions and graphical models may be the best approach. For small systems, we can start with the user scenario analysis only. So the user, based on the user analysis, we can go to the architecture and the design phase. So next we comes to the validation phase, where we have to find all the errors in the requirement specification and fix them. So it follows sometimes it follows a formal review. Many times the technical review is also done that looks for the errors in the interpretation. So the correctness and the accuracy of the requirement are checked. Areas where more detail or clarification may be required. So there may be some ambiguity the way we interpret it. So we need to give more details and information that could be missing or omitted. So we have to look for the completeness. Nothing is missed out. So that the requirements, everything has been documented. That we have to see. Differences or conflicts between the requirement. This is a major problem. So this kind of inconsistency has to be identified at the time of validation and properly removed. And the requirements, sometimes the requirements could be unrealistic, that means unachievable. And for example, there could be some performance parameters that the customer is expecting, but the technology that we are developing, it may not support it. Similarly, there could be some technical or environmental issues, like it may require some external interface, but we may not be having the right kind of the telecommunication setup if we are doing that. So if it is expecting something to come from outside or something to go outside, we may not be able to do that, or maybe the software that we are using may not give real time transfer of data to external systems. So these are some of the examples that I am trying to state to understand why sometimes the requirements may be unachievable or unrealistic. So we have to remove all these unrealistic requirements from the specification at the time when we are doing the validation, and we have to either scale it down or we have to reword it in more realistic manner. Then we come to the requirements management. In the requirements management, our aim is to help the project team to control the changes, because these requirements have to remain as a active set throughout the life of the project until we have completed, we delivered, and also in the maintenance phase. And during that time so many changes will come. So that change control is one of the major objective of requirements and management. It is a set of activities that help the project to identify, control and track the requirements and all its changes. So not only that, it has to be managed in a configuration controlled manner, it also has to be tracked. So whenever there is a change, we have to see how it will be tracked to the relevant work products. Whenever there is a requirement change, we have to track it to the relevant work product, and we have to see that the work product has been adjusted for the change. So when requirements are identified, each one of them is assigned a unique identifier. So unless we give a unique identifier, it will be difficult for us to track the requirements and also its changes. And its conversion to the design and code will be difficult. So this is the purpose for which we have to index it, or we have to give an identifier or a number to it and index it properly. Then to help us to do this tracking, there is a tool that is normally used which is called a traceability table. It helps us in satisfying the traceability. It will track the requirements to closure. That means whatever requirements we have done, we have taken it to the end of the development phase and we have delivered it. And also to find if change in one requirement will affect some other aspect of the system. That means there is a dependency on the requirements. So when we are making change to one requirement, it will also affect the other parts of the requirement. So if we have already constructed it, then we need to make relevant changes in it. So that tracking also has to be done. So that is the use of the traceability table. So because of this, we have to understand how the traceability table is kept. It will have so many different kind of features in it, different kind of information in it. The first one is the features traceability. It will depict how requirements relate to features. So whatever we are talking about the software feature, how the individual requirement that is specified, that is the index that we have given, or the unique number that we have given, the ID we have given to the requirement, how it matches to the particular feature that is observed by the customer. Then we come to the source traceability table. That means from what is the origin of that requirement, who has given it and how it was given, how it originated. Then we come to the dependency traceability. It provides the relation among requirements. This is useful for the change management. Then subsystem traceability. So because when we actually try to develop the system, we categorize the requirement to subsystems, to groups, to sets which are related, and those related requirements normally form a subsystem. So when we keep the subsystem traceability to the original requirement, then it is useful in tracking the requirements to the design and the construction, because we know which subsystem it has gone. Then we can have some interface, because user interfaces will be there. So we have to track the requirements to particular interfaces, the relation of the requirement to the internal and also external interfaces. So having done this, now we have to see, so we have completed the different phases of the requirements activity, and we have also seen how it will be tracked. Now let's discuss something on the requirement specification, because requirement specification is the final document which is consisting of text, models, diagrams and many other structured information regarding the features and the other behavior of the software. Because this is the major output from this phase, we need to understand a bit more about the software requirement specification. So let's look at the principle which we have to follow when we create the requirement specification. This can be viewed as the requirements representation process. Separate the functionality specification from implementation. So always we have to uh, create a difference, we have to understand that specification of the functionality is not implementation. Implementation is something different and specification of the functionality is something different. Normally as software engineers, we always think that the moment the user tells us a problem, we have to go implement it. That means we have to make some code and see whether it is satisfying it. But this sentence is basically telling that we should not do it. We should first make a functional specification. We have to this is a separate phase and we have to create it and we have to agree with the customer that this is what exactly we are going to develop, and then we have to jump to the design and the construction phase, which is the implementation. Then develop a model of the desired behavior of the system. So because it is very difficult to because the users cannot express properly, and also it is difficult for the software engineers to understand all aspects of the business, so it is always better that we will develop a model. So that is one of the principles of the software requirement specifications. Always we have to create the model and include it into the specification, which will give the desired behavior of the system. And we have to establish the context in which the software operates. So that is also another important thing, the environment, the business environment and the context under which business scenarios it is working, that has to be established in our requirement specification. Define the environment in which the system operates. The operational environment also has to be established. So here we are talking of the business context and here we are talking of the operational environment. And create a cognitive model. When we say cognitive model, means something that we can understand, a conceptual model, rather than a design or implementation model. So again, when we go to the design phase or the implementation phase, when we go to understand or study the software engineering phases of design and the software engineering phases of the implementation, there we will make more models. So here we are not going to make design or implementation models, they are separate. And the models that we prepare in the requirement specification are more on the cognitive domain. That means they are more for understanding the way the user can understand. It is more on the perception level. They describe the model as perceived by its user community. So how? That is why I said that the user should be able to understand it. The way the user will understand, that kind of model we will make. The specification must be augmentable for omissions. So we have to take into account that humans always can make errors, and because human beings can make errors, so there will be some omissions at the time we will make the specification. So we have to write our specification in such a way that it can be augmentable, something can be added later, and we will have to establish the content and the structure of the specification in such a way that it can take changes and it can be tracked. So these are some of the basic principles on which we will try to specify the requirements at the end of the requirement engineering phase. So then we can look at some of the conventions that we follow. The format and content should be relevant to the problem domain. So when we use those symbols, diagrams and language, they should be more on the domain. Whichever is the domain that we are using the software, that domain language, that domain symbols we should use, because it needs to be understandable by the user. We should not use a language or a terminology that software engineers use while doing the programming or by when we are using the compilers or other technical tools of the software development. We should not use our language, we should use domain language, business domain language, and we should use them less. Information content structure should be nested, it should be layered. So that means we have to use paragraphs, we have to do indentation, we have to use diagram which should be numbered, there should be a particular scheme, and also we should keep doing it at different levels. That means we should first give the higher level information, then we should go to the next level, a little bit more elaborated, then the next level more details. So then it is easier to follow. The contents should be properly structured in a nested and layered manner. And sometimes it is worthwhile to present the same information at different levels of abstraction to aid in understanding. Then we go to the notations that we use in the diagrams, models, forms, lists, whatever is the structural way we have used to write our specification. What are the notations that we will use? Those should be limited. The number of notations we use should be limited, and it should be consistent. The same notation should be used throughout the document. It should not have a different, so that means in the for page 1 we will use some notation, and in page number 10 a different notation is used. That is not proper, it is not consistent. So we have to be very consistent how we do use our notations. So otherwise it will be very confusing, and these can be for graphics, symbols, and anything. When they are inconsistent, they can create some confusion, and they can give the wrong information to us. Representation should be revisable and undergo change control. And finally, let's look at the contents of the software requirement specification. Now you will always hear this SRS is a very common abbreviation that is used in the software engineering field. So what SRS actually stands for is specification, software requirement specification, and it is the major output from the requirement engineering activity. The SRS is expected to contain the complete information description, including detailed functional description, system behavior, performance of the requirements, design constraints, any validation criteria, or any other information regarding the requirements that will affect the design. So anything, because this SRS will go as input to the design phase. So if the SRS is not complete in all these areas, then we will have problem in making a good design. So let's look at the format, what all it will contain. It will have an introduction which will state the goals and objective of the software. Then it will have the information content, that is the how the information is flowing in the software system that will be developed, and the structures are documented: hardware, software, human interface, that is the user interfaces, that has to be described for all the external elements and the internal software functions. Then the functional descriptions, we have to give narratives. Each process has to be identified. That means each functional business function has to be converted into a process for our design. And these processes, which are basically transforming the data in the business functions, they will require a narrative for each function, and also the constraints which will be written, and any model that we want to do, and the performance characteristics of that particular function has to be mentioned. Then we come to the behavioral aspects. Describes the operation of the software as a consequence of the external events and internally generated control characteristics. How the software behaves when some data is input, or some other event happens, or some trigger comes, or either internally or externally. Then the validation criteria, that means how we will test and validate the user scenarios. What is the data, what is the way we will do it, what is the expected output when we try to validate this user scenario. So the validation criteria has to be there, and at the end of it we will have some appendix which will contain any additional information relevant to the specification which is not part of all these items that we have discussed, and also a bibliography. The bibliography will have the references to the documents that we have used in creating the SRS. So at the time of doing the requirement engineering, we might have taken so many documents either from the customer or some standards, some guidelines, all these things we might have taken. So all those documents that have been used to create the SRS will have to be mentioned in the bibliography. Then we will, after doing the this content, it will be we have seen that there is a validation phase. So there is a specification review. A review of the SRS is conducted by both software development team and the customer. And if we have created a prototype, then that also will be thoroughly tested. The demonstration will be there and it will be tested. Initially, the SRS will reviewed at the very higher level or a macro level for checking of completeness, consistency and the accuracy. But later, as we go to complete the review, we will have to do a detailed review for examining the information content, the functional content and the behavioral domain. So whatever are the models we might have created, those have to be checked for again these criteria: completeness, consistency, accuracy and those things. Finally, we have to also check the language and the wording, that because we said that notations are very important, and the way we write it is also very important. It should needs to have business domain language, and then there can be some vague words, because instead of writing the exact word, we might have used words like sometimes, some, often, usually. So these are confusing terms. So these kind of confusing or unambiguous terms, words have to be removed, and the proper clarification has to be obtained by the reviewer at the time of reviewing, and these kind of problems in the system specification has to be removed. And we have to, at the end of it, we have to do the sign off by both customer and the developer. Once it is signed off, what will happen? It will become binding to both the customer as well as the development team. So it becomes something like a contract for the development team. During the review, changes of the specification may be recommended, and as and when they are recommended based on what we have discussed in the previous slide, those specifications will be changed accordingly. But once it is signed off, request for changes later on will be considered as a change request, and it can be extremely difficult to assess the global impact of a change, that is how a change is in one function affects the requirements for other functions. So once the requirement is frozen and we have started developing, we have gone to the next phase of the development, each change will have to be properly assessed for the impact of other changes, and all the changes will have to be taken into account when we try to see the cost and the delivery effort that is required for affecting the changes. Any change is an extension of the software scope and therefore can increase the cost and the delivery of the product. So this has to be kept in mind when we do the specification review and agree on it. So we have come to the end of the slides to this lesson, and thank you all for giving me a patient hearing. So I think we have understood what is the system specification, and we have also discussed the importance of requirement engineering to produce high quality software, and we have also seen the challenges that we face, and we have gone through the distinctive activities that we carry out during these phases, what are their objectives and how do we take it, how do we carry it, and as I have said, we are also seen the SRS. So thank you all, and in the next class we will be discussing more on the different phases of the requirement engineering.